So for transformations, we're going to start with our parent function. F of x is equal to the square root of x. And again, the only way that we can graph these is by doing our xy tables. So let's go ahead and choose some x's that we want to use. What would be some good x values? 0. What else? 2. Yeah, we can do 2. 1. What's the square root of 1? 1. It's the one we always forget about. No pun intended. X is 3. That would be, no, not x is 3, but
4.
Yeah, we actually want to stay away from 2. We actually want to do 4 and we want to do 9 because, again, we're taking the square root of those. That's why you contracted 2. Okay? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So we go to our plane 0, 0, 1, 1. And this is the graph paper that Devin gave to you. 4, 2. 9, 3. We start here at the origin and then we take off to the right, slowly starting to climb upward. This is our parent function. So what we're going to do today is we're going to take this parent function and we're going to apply the transformations to it and then come up with our new graph. So we're going to begin by looking at this g of x, which is equal to the square root of x minus 7. What do you suppose the minus 7 is going to do to this thing? It's going to move it. How so? Kendra? Up or down, do you think?
Down.
Down. How many units? We're going to move it down 7 units because, again, the minus 7 occurs outside. And, again, the Spider-Man analogy. If I'm outside the building, okay, I can move vertically. So it's our vertical shift. So we're just going to take all of our points and we're going to move them down 7 units. Okay? 1, 2, 3, 4, 7. There it is. Let's try this h of x. Again, going back to the original. Square root of x plus 9, where the plus 9 is now on the inside. Now what is this plus 9 going to do to our parent function? Horizontal or vertical shift? Horizontal, because it's on the inside. Now Spider-Man is inside the building. He can only move horizontally. Left or right, 9 units? Left. It's always the opposite on the inside. Plus 9 means we're going left. And there we go. Let's go to the next one. Let's look at this j of x, which is equal to negative square root of x. Now, if we put a negative on the outside, what do you think could possibly happen? Let's go here. Let's go back to our parabola. What were you taught if we put a negative value out in front here? Yeah, it went down, right? So in a sense, in terms of transformation, what was that? What is that? Yeah, it's a reflection. Very good. So if it could correspond to the radical function, we would say it's going to be a reflection downward. I'm not 100% convinced that that's what's going to take place, so let's go ahead and do an xy table for this one too. Let's use our same x's. We had 0, 1, 4, and 9. And if I plug 0 into this, okay, I can't have negative 0, so it's still 0. Square root of 1 is 1, but it's negative, so it's negative 1. Square root of 4 is 2, so negative 2. And negative 3. So if we plot these points, 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. Did our conjecture hold true? Yes, it did. It took the parent function, the black one, and it reflected it across the x-axis. It reflected downward. So that's what the negative sign in front is always going to do. It's going to reflect it down. Let's take a look at one more. Yeah, this one. K of x is equal to 1/2 the square root of x. Okay, let's go back to the parabola because we really knew that one. What if I change this out in front to be a, I don't know, half? What did it do to our parabola? It did a vertical compression, right? Okay, it made it fatter, so to speak. If this was a 5, it would make it skinnier, right? So we're going to apply a vertical compression here. But how much? Again, we can do an XY table to see this thing take place. Let's go 0, 1, 4, 9 again. Square root of 0 is 0, half times 0 is 0. Square root of 1 is 1, half of 1 is half. Square root of 4 is 2, half of 2 is 1. And the square root of 9 is 3, half of 3 is 3/2. So again, if we plot these points, there is 0, 0. Here's my 1, half. Here's 4, 1. And here's 9 and 3/2. So essentially what it did is it took all of our points and it split the distance between where that point was at and the x-axis, right? Okay, it compressed it by half. If it was a positive value, okay, or if it was 4, it would times it by 4 and make it that much bigger. So those are the different transformations we can do. We can do horizontal, we can do vertical, we can do a stretch or compression, we can also reflect this thing. So for example number 2, we're going to do all of these in one. We are going to use f of x, which is equal to the square root of x, and we are going to apply these transformations to the g of x. Let's begin by plotting f of x is equal to the square root of x again. There it is. The thing with transformations, when you're dealing with more than one, you have to make sure you do these in the correct order. Okay, because you just can't apply the vertical and then go back and apply the horizontal, or else you'll end up with a wrong graph. Okay, last period we learned that the hard way because Mr. Dorr forgot. But step number 1, the first transformation you're going to make is the horizontal shift. If it's there. If it's not there, you can move on to the next one. But let's take a look. Horizontal shift, okay. I know it's on the inside, so I need to check to see if we have anything on the inside of the radical, and we do. It's a -4, which means we're going to move this thing left or right 4 units. Right. Very good. So right 4 units. So let's go ahead and move all these points accordingly. And I'm not going to pause the last one because it's going to go off our screen, but that's okay. Second one is now going to be the vertical stretch or compression. Vertical stretch or compression. And we said if we go back to the parabola, that was the A value that was out in front of the parentheses. Do we have an A value out in front here? We do. It's a -1, but it's the absolute value is still 1. We'll deal with this negative here in a little bit because that again was our reflection. So for this one, nothing. So let's go to step 3. Step 3 deals with our reflections. Here it is. Now we're taking a look at this. We're going to address that, which the negative out in front did what again? Well, it flipped it down. Reflect it vertically. So as you go about doing these, remember if you have to build off of it, go off of what your last transformation was. This is where we finished. We had the red one. Now I'm just going to take it and I'm going to move it down or reflect it downward. So this is where I'm at after the red and the green. Last thing we need to do is our vertical shift. If we have it. If we go back and take a look, vertical is outside, that's the +8. So now we're going to move this thing up 8 units. We finished, or we left off with the green. So there's my 8. So when you go to Desmos and you check your answer, you're going to see something like that. The order is the toughest thing to remember. It's horizontal, vertical stretch or compression, reflections, and then the vertical shift. HVRV, I guess. Whatever that means.